Okay, we're live. And it's so obnoxious when the internet just freaking crashes on me. Get restream back up. Yanni token. Okay, cool. We're gonna start with reproing this experiment. This one. Two. This one. Okay, so this was our previous, I think, best one here. And then there is yeah, there we go. I think this was good about, this is a good reference. So we will see. This one has a fair bit of overhead to it. Not getting stuck now, are we? Lack of stability is killer. We'll try without the initialization as well. Maybe the initialization is screwing it up. So unstable. Now you got to remember, right, that there's also a selection bias here. So the Brown curve is like you ran a whole bunch of experiments and then you're looking at the most stable of them. Because if we looked at the most stable one of this one, it also looked nice and smooth. And this is still either solved or very, very close to solved with this run. Yeah, there you go. That solved for 862, yeah. Yeah, okay, so this is also solved. These both solved at 100 mil. I'm going to take the scaling out just in case and the clamping. this out. Just in case. Dude, that doesn't even necessarily mean that this is bad or anything. It just means that possibly the hyperparameters don't agree with it. We'll run it like this next. We'll see what that does. But these are the results we need. These are the results we need. Honestly, this is starting to look on par. Because if I just copy this, right, we also have the other breakout sweep a while ago. I believe this was the good one. Okay, so this is the other breakout sweep. We have this Pareto front. Right here we have solved in 279 seconds. This is the best. And mind you, there's about a 20% overhead, it looks like, that we've added with this extra function. So, and we're going to be able to remove that. Also, 538 and 162. This portion of the curve looks better, which would suggest to me that probably the whole curve is better, right? These tend to be very steep. We're definitely going to have to see. What's going on over here? All right, this is something. It's pretty close on the original. I'm pretty content to just keep running these experiments tonight. It's gonna be big. Be very big. This is kind of wild. To give you an idea of how significant this would be, any reason why you implemented your own Pareto genetic sweep instead of other libraries? They don't have that algorithm and mine's better. Simply enough. They don't have the algorithm. My code is better. Guys, this seems more stable, better. Also, to give you an idea of how substantial, I mean, this is just like me fiddling with research experiments right now, but to give you an idea of how substantial this would be, if I get this working like across the board, and I match GAE, then this would be the first general purpose, like drop in, pretty much zero cost improvement to PPO since 2017. This would be like the first major algorithmic, like general purpose algorithmic improvement to RL since 2017. What do they even have in RayTune? They even have anything good in here now? To their credit, they have a lot of the algorithms. I think ours is better though. But here's the funny thing, right? You have all these libraries for this. Here's my code. If we ignore the comments, it's like 500 lines. I think it's less than 500 lines if I remove these redundant comments. This is the new algorithm. All right, this is Pareto genetic. It's one screen. Yeah, I do require Pyro for the new algorithm because you need Gaussian processes, but that's it. Want a clean code? Then you use this, right? You use our stuff. We have the shortest code. Shortest code, lightest dependencies. Puffer is the place to be if you care about performance and simplicity, right? If you care about tons of options and bells and whistles, Puffer not the place for you, right? But if you want the thing that works as simple and as fast as possible, that's Puffer. Puff up your reinforcement learning today. I want things I can hack in. Well, Puffer is very easy to hack because it is very short. Try Puffer. Exactly, they make it hard. Puffer, we make it easy. Why do difficult thing when easy thing just as good? So now this works. And the only thing I really need to figure out is how to make this robust to different value prediction horizons. That's all I need to sort out. Oops, I missed some messages, it looks like. Okay, we'll see how this goes. There are kind of two things that could happen here, right? One is that this just doesn't work as well when you increase the horizon. But what I'm hoping is that there's just like a startup period that's longer while it figures out how to adjust the effective horizon. Okay, I'm trying to think if there's any reason why it would be fundamentally harder with longer horizon. I don't think so. I wouldn't think so. Actually, the opposite. It should be better. Why is it not better? Increasing horizon should grant more capacity. Doesn't seem to, though. It could just be the advantage function being silly. If we're looking at initialization versus advantage function, probably advantage function is the place to look, right? Yeah. Captain, these are both no GAE right here. The only thing we haven't figured out yet is how to make it robust when you have longer value prediction horizons. What made it so much faster? Hyperparam sweeps. We had to redo hyperparameter optimization. I mean, we still have to do. Yeah, I know, it's huge, right? The thing is, we still have to do like major experimentation. But this is what I'm saying. Like, if you want to get involved with the experiment side, I'm fixing RL. Like, this is not like little like shitty research. We are actually going to fix RL this year. Right? Like, literally, as soon as you point PufferLib in the general direction of something and you do research at this speed with like any degree of competence, stuff solved. I mean, literally, if you were running this on CleanRL, you would be waiting weeks for these results. SP3, weeks for these results. You wouldn't even be able to implement the thing as easily because, like, you'd have to go dig through SP3 algorithm code. Puffer, very good. Gotta go now. You let me know when you're around. I briefed Spencer already. Whenever you want to get involved, we'll be here. Okay, so this is very nice and stable. It underperforms majorly. We're gonna figure out why. Yeah, so okay, this is the nice stable curve. It's just there's like some noise or something. So we'll figure this out next. So yeah. The next thing I would like to do is we will compare this run do this. So we are setting the scale to 0 beyond 32, and we see what this changes. I don't know, this guy. So still lagging, right? Now the question I have is this going to be on par with the original or not? It looks like it's a bit steeper, but it's very early. So essentially here, right, if this doesn't work, if this works on par with this, then the error is coming from the NLL loss somehow. And if it does work, then we're set. And if it's in between, then I don't know. Welcome, folks. This is evening algorithm dev, and mostly a bunch of experiments. We'll see what this is on par with. So I've had results before where it doesn't seem like doing this alone fixes the problem. So if that were the case, then the only other place the problem can come from is the NLL loss, right? Okay, so you know what we'll do next is we'll mask the loss. So if this doesn't give us on par performance, we'll mask the loss, and that should have to give us on par performance. And then maybe we'll do it the other way around, so we mask the one and not the other. So this just crashed. Weird. So we have a plan. This looks like it's going to be on par here. Unfortunately, we do need to do the whole runs on these. They are slow. I'd really like to know about this 34% though. Presumably, I just have to find a way to make the Scython faster. It's fine though, we're chilling. I guess I can just think about some plans for this. So I don't think it's going to be quite time to merge this yet. I still want to test the hyperprim sweeps independently, not on this. Yeah. So we're going to refine the hyperprim sweep stuff a little bit. Breakout seems like a very good end for fiddlings with stuff. Train's pretty fast. Sweeps don't take too long anymore. So probably I'm going to play with the last remaining things that I wanted to play with on hyperprim sweeps over there. And then we'll probably start running benchmarks on, well, we'll merge that into this. In parallel, we'll start running sweeps on both for all the different M's. I think the new sweep algorithm is efficient enough. We probably don't need 200 experiments per M. Probably only need 100. That'll also give us good evidence on this algorithm. What would it imply if this is slightly above the other one? The NLL loss. Oh, if this is slightly above the other one, it just implies that at least some small amount of the performance drop is attributable to the computation of the advantage function. That's all it implies. Yeah. Which would make sense. And then NLL is the other part of it. But the thing is, I don't know how we fix NLL. Like, why would that be a problem? Why would computing an NLL loss over more, or was it Gaussian negative log likelihood? Why would computing that over larger sample create more error? I don't think that's how the loss should work. Knowing that I still have to run the full thing for the end state, but how's this gone in the meantime? Ooh. 330 score in 100 seconds. For reference, this is about how well original like SV3 and CleanRL does in I think an hour or two. Get a nice burrito front here. Burrito optimal. For the folks watching, all this is on puffer.ai, including the latest commits. All the dev branches are public. You can play with all this, the results right as they come out. Start the repo if you do. It really helps me out. Pretty much I just track stars on the repo and kind of X followers. That's pretty much it for growth of PufferLib. The reason I have to wait for this whole thing is because the end state, sometimes it can jump up at the end quite a bit. But this one looks to have been pretty stable. Oh no, we get the spike at the end a little bit. 650. It's about on par with this one here. So next we mask the NLL. What happened? Inf. It's other way around. 32. There we go. So this should be identical to the original run. This is meant as a hard check on the horizon if something screwy is happening. Because now I have horizon 128, but I have everything mapped to be the same as 32. So if this doesn't work, then yeah, something's just really screwy. And then that's most likely just a bug. So we just have to go hunt the bug. Given that it looks like there is one, we can start looking for it. Okay, the first 32 elements, and this is a mean, so... Oh. You're stupid. You have to be really careful with these things. You make dumb mistakes. Well, at least I make dumb mistakes when I've been doing this for, most of the day. That's more like it. I still don't know if this will match. We will see. Oh, you know what? Could that have been it? If I took the mean over the loss? It could literally be a scaling issue, right? Let's see what this does before we make any conclusion on that, but it could literally be a scaling issue. If most of the signal is in the first spot of the first chunk of the loss, and we take a mean, I wouldn't think it should be sum over the last dimension though, right? That would be weird. To think about it. It sucks that there's hardly any RL news on X anymore. Like everybody's just gone and done LLMs. That's funny. Where's the RL? If only people had AR tech, this is like a fun gimmick. It would be so easy to get RL working on an end like this. It's a fun gimmick, but these don't actually, these don't. Like, nobody's gonna, like, look at a thing through their phone and be like, oh wow, it renders in 3D on my phone on the camera. We got 309 and 30. Is that any good? Oh yeah, that looks on par with the other runs. You still have to run the whole damn thing, but it could just be a whole scaling issue. Question is, what do we do if it is a scaling issue? And why would it be a scaling issue? If you take a mean, I mean, it's like, what do you do instead? You take a sum? A sum doesn't work either. That still doesn't scale perfectly. I'm gonna fiddle with the scales a little bit. There's so many versions of this to run. That's gotta just be drift, right? That it's showing up as better. Yeah, it can't possibly just be better. It's the same thing as before. Yeah, there you go. It's just some drift. But if it's on par, then we'll have to just figure out if it's scaling or what. If it is scaling, it can't be credit assignment, right? No. There really should be no way for that loss to be messed up. Unless it's a network capacity issue, but I don't think that makes sense here. Oh, here's a dip. But this is not uncommon, right? The other experiment dipped as well. That's not, I mean, that's not a killer here. It's already back up. Yeah, there you go. I'm gonna call this curve a match because this one bump is like common and the endpoint's the same, the general shape is the same. And make sure the endpoint's actually the same. I do wonder what it is that causes this type of thing though, right? It's like temporary policy collapse and rebound. This can't just be random noise. This is too big for random noise. Random noise is on the scale of like these little jaggies you see here. This is like genuine collapse. Is this collapsed back again? No, we're good. Okay, so that's the repo with 128 with everything masked. Provided this is not gonna screw up here. I mean, even still, it's like, it's there, so we're good. So now, okay, so this is the repro. And then we'll do, this will just be mean of 0 dot sum over 32. So we're gonna try this one. So this is gonna take the same scale and basically just assume that the last elements don't contribute anything. It's probably not a great assumption. Is there a VLOS norm on here? There is no norm on VLOS. There's a clip, but not a norm. Norming value loss seems fine. Oh yeah, that's a full solve. 864 is fully solved. We're not expecting this to match. We're just expecting this to do something in between. Okay. So exciting. This is slower. Again, all this has to do is land in the middle. And then if this does land in the middle, then what we do is we take some sort of normalization and we throw some normalization on it. 6. Let's see. Well, okay. That's something. We still have to do this without the clipping, and then if this all works, then it's just pure normalization is the issue. There might still have to be some clipping, we'll see. But essentially, if we're able to match, it means that we should be able to have, it should be horizon independent. You should be able to give it a longer horizon and it'll either do the same or it'll do better. Those longer horizon environments will make use of more of the value function. It's flattened out. We'll see terminal behavior. A lot of progress? Oh yeah. Potentially revolutionary progress for the field. If this works, this will be the first major first major general purpose algorithmic advancement in RL since 2017. Preliminary results are very strong. Preliminary results are very strong. There are just a few things we have to fiddle with still. This curve is a little weird. It was matching. Does it slow down? Well, again, we didn't expect it to be perfect, so that's kind of okay. The only thing we needed to do is to be better than the bottom set of curves. If it full solves, that's a bonus. Then you would have been working through. Save material for 3D. What is this? So the The thing to keep in mind, holder for loads, it gets blown up every time we fire. It's funny. There's already good generative models for CAD. The thing to keep in mind for RL, right, is you're looking for interactive processes. You're looking for interactive processes that have a clear action to be taken to modify the simulation, feedback signal. Well, no, but I wouldn't necessarily class it as an RL problem either. I don't know, people have gotten some stuff out of them. But if you're just designing holders for things, I think you can just do that. Doesn't take much AI. Really doesn't take any AI. Okay, there we go. A little bit unstable, but generally pretty good. Slow wave structure. What is a slow wave structure? If you have a thing that you're simulating as, well, I'd have to look at it and see how I would cast it as a problem. It produces microwaves through some Russian name effect. Cherenkov? Cherenkov. Azation is fun. It's cool. I might be able to RL some things. Produces blue light in nuclear reactor. I didn't know that was a thing. Electrons moving faster than... Wait, electrons moving faster than the speed of light. Electrons can move faster than the speed of light? Wait, is there a thing that, is there actually a loophole in speed of light? Is there a speed of light loophole nobody told me about? This is very, very close, so I'll call this a match. This is so darn close, right? In water, electrons can move. Oh, in the material. So there isn't an exploit on the absolute speed of light. There's nothing that goes faster. Damn it. I was hoping you were going to tell me there's a loophole. Okay, this is very close. You got me excited. I would love the speed of light loophole. See, because if there is any sort of speed of light loophole, I bet that we're going to be able to have like faster than light travel and stuff, and that would be pretty cool. We get to have some sci-fi stuff. Uh, if you can produce antimatter, make an engine that gets close to the speed of light, you would feel no time. Yeah, but then you would get the like shitty version of sci-fi, right? In which like you don't feel any time pass, but everybody else feels years of time pass. That's like the shitty sci-fi version. Now we want the sci-fi version where it just freaking works, and then we can just like hop all over the universe whenever we want. That's the cool one. Don't think I can crack that one. Yeah, we'll wait for AI to crack that one. I think AI has got to deliver us at least one crazy sci-fi thing before we really take it too seriously. We at least have it has to give us like one crazy thing straight out of sci-fi. Well, hopefully not that sci-fi. I'm thinking more, culture series or something. Need to focus. Well, you don't take it too seriously. The thing is, what's possible now is pretty boring. You gotta have something to get you to get up in the morning, right? Well, as you can see, I am here doing the work. Would we like to check the number of dev hours streamed this month? It's quite a lot. 2 major breakthroughs this month. See if this is a little less. I wonder if we should also try this with the clipping. The clipping should be the same, shouldn't it? I mean, I guess we'll look at it. Clipping should be the same. We'll have to try that as well. A lot of just manual experiments today. When it's for something this big, I don't mind it. How big of a jump? So let's say that it performs exactly the same as generalized advantage estimation. Okay, let's say that that's the bar, that we get it to work exactly as well as the previous one. You just make your existing, you change this form of your existing loss terms. You make the loss layer bigger, but that should be essentially free. And you delete two very fiddly hyperparameters from the algorithm. You no longer have to sweep two hyperparameters. That's the cool thing. No, it doesn't cut down the compute on a 1 million parameter run. It cuts down the hyperparameter search. So that means a few things. First of all, you have to run fewer experiments in order to get optimal hyperparameters. And second, it is much, much more likely that you will be able to use the same hyperparameters across many different environments and have it perform quite well out of the box. So this would be a large step forward for out-of-the-box reinforcement learning. Pong to other games, maybe Pong to other sims entirely. You cut out, I think it's probably the second and the third most fiddly hyperparameters in RL. So you cut out two of the top three, most annoying hyperparameters in RL. Yep. Gamma lambda. You can tune a hyperparameter, but you can't tune a fish. It's true. Can't tune a puffer. Public service announcement. Do not take puffer fish out of the water. Inflating them with air kills them. Do not do that. They are very friendly creatures. I saw one snorkeling like a month and a half ago. They're very amusing. Okay, so this is better than the other ones, but needs maybe clipping. We'll try clipping next. I was on vacation. I wasn't snorkeling in Florida. I think in Florida you can technically find some manatees, though. That would be cool. But I can also literally just like take a 30-second walk outside and just see alligators just chilling by the side of the pond. Freaking like 8-foot alligator just chilling there waiting to chomp you. I have no idea why those things are protected. That could be a winter's worth of jerky and a new pair of shoes. And one less thing to worry about chomping you. This is a bot. It's funny. Wait, I just want. See. 120 mil. My question is this going to track the previous one, or is this going to track this one up here? I would think that it should have to track the one up there with the clipping. We will see, though. I think I'd argue that this is actually simpler to implement than the original PPO as well. Generalized advantage estimation is really awkward to implement. This is a lot easier, I'd say. Would you ever try fugu? No, leave the puffers alone. Man. Leave the pufferfish alone. They're very friendly creatures. I think if there's anything I can do on this here. I don't think there's any great way. I can always optimize to see. This freaking. Funny. This is honestly true though. Oh, but somebody reused this picture. There was a post on this earlier that, yeah, like, if you go anywhere but SF, you can just get a house with like a 1K mortgage on it. Just build whatever the hell you want. Would you ever go where? To somewhere in the middle of nowhere instead of SF? I'm currently in Florida. Not exactly the tech capital of the world, but I'm building whatever, right? I've been there. I don't plan on going back. It's kind of just a shitty and dangerous city at the moment. I don't know how many more founders have to get attacked in broad daylight before it's like, yeah, this is just a stupid place to be. I'll be spending a good chunk of the summer in Palo Alto instead. 45 minutes south, safe, nice, cleaner. Yep. Now, Palo Alto's nice. Mountain View's nice. I mean, honestly, a whole bunch of areas are nice. Okay, so I'm interested to know why this didn't match. We'll let it finish to be sure, but it doesn't seem like it matches. Okay, so the fact that that doesn't mitigate is kind of weird. Like, I should be able to print out. I should be able to print this here, right? Hey, welcome. I'm an undergrad. Huh. Stupid. Think what you're doing is really cool. AI master's student, SMU, learning a lot from your content. Thank you. At the moment, it's mostly just chill and run experiments. But if you just got here, the particular experiments we're running right now could be a particularly major breakthrough, let's say. This would be the first general purpose enhancement to PPO since 2017. Egos through the roof. I mean, I think I had a hell of an ego in undergrad as well. To be fair, I was kind of doing all right by then already. But I don't know, I like brash people. You better damn well be right, though. If you're gonna be arrogant, you better be right. ROTC. I had one good friend do ROTC. I don't know where he went after that. He's probably in the Air Force now. Oh, hang on. There's just a ton of variance in these, isn't there? Yeah, I'm looking at this thing now. I think there might just be a ton of variance. That's a good data point. I know I've never been super big on chain of command. Well, I guess I wouldn't. It's not. We don't have any links to military with my stuff, right? So there's not really a chain of command or anything. I mean, there's a don't be a dick rule, right? Pulse power mafia. It's funny. Can you explain to me how it is that the devices that you would make would be able to be like sold commercially to like farmers or whatever if you need to detonate C4 every time you have to charge something? Can you explain how that works? One of the students have expanded across many domains. That's cool. I had a fair bit of breadth in ML in my like early 20s. I had quite a bit of breadth, but now I'm pretty specialized in what I do. I'm good at picking new stuff up. I'm pretty specialized. And yeah, just by random chance, that's perfect learning curve right there. That's a perfect, like that's right on par with JE. It's actually a beat JE. That one's military. Research, do more industry. Make your company, they can do it all. But is there, I mean, are there like you charge the capacitor and it's like a single use thing, or I'm just trying to figure how does it work if to recharge it you need to detonate C4? Is that a thing? Applications that run 24/7. So presumably you're not constantly detonating C4. Unless you are. Constant C4 detonation. They take out enemies. Radame. Or EM hardened drones. That's cool. That is definitely cool. If you like drones, then RL is the way that you would train the maneuvering of drones. RL is the way you do it. It's like a perfect RL problem. Close, not kinetic. Yeah. Highest energy density. Limits required on navigation. No. I mean, like, if you have 100 drones, okay, and you want the 100 drones to be, like, perfectly coordinated in a way that's completely superhuman and above any ability that we could program algorithmically, like, directly, you use RL. That'd be a fun thing to work on, to be honest. We should do that. We should do. I mean, I could even sci-fi it a little bit up, and I could just make like a swarm ship sim. That'd be fun. Big money. Oh yeah, of course. If my primary goal were money, I wouldn't be doing this. At least not in the way that I'm doing it. It is a goal, but it is the secondary goal. Money will come. Money will come. How do I get in on the swarm sim? That's the thing, you literally just start doing stuff. You just start building stuff. There's no gatekeeping here. Here, I'll show you 1 second. Okay. So, here. I built this environment. I built this environment. I built this environment. This one, 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 and this one were all just people, contributors, who showed up and were like, hey, I want to build a thing. How about this? And I said, go for it. And then I just, gave input along the way and helped. But yeah, literally you just start building sims. And then Puffer makes it fast. We have all the resources you need on this stuff. It's much easier than it looks. You don't have to do like complicated you don't have to even do like physics sim at the level of the propellers and like the airflow and all that. Like literally if you just did like ships in 3D space having to like coordinate to do a thing effectively. Yeah. I mean, this is pretty much how it works, right? I get dozens and dozens of people asking me like how to get involved in RL. I tell everybody, look, you literally just show up and build these sims. And then the ones who stick around become, active contributors, and they get hardware access. Active contributors get access to our hardware, and I do code reviews, and they get a lot of good information. Hey, I invest time in people who invest time in Puffer. That's how the open source works. It is remarkably, remarkably easy to get involved. You just put in a little bit of the time. Ultimately, we want this to be quality open source stuff. We just need people building these environments and testing stuff. Actually, 2 of the contributors now have done so much stuff on Puffer that I'll be onboarding them onto some of the more science side stuff that I do. I've done 1 onboarding already. Open source is very good. This one I don't entirely understand. Like, does this just work? I doubt this works, right? This is probably unstable. Not some. Yeah, that's unstable, right? You can see the value loss. That's tiny. Open source, waiting on first citation. Did you just publish this? Oh, you have a few, you have several. I don't even have the Google Scholar profile, I'm pretty sure. February 1st, congrats. Nobody's published RL in the field, yeah. RL's hard. Well, it depends what the search dimension is. I can probably do better than genetic. And the value loss like this. There's a value clip, but there's no value norm, it looks like. Genetic algorithms are much easier to get working than RL, which is why a lot of people just start with them, but they don't work anywhere near as well. Like, they're easier to implement, but they don't work anywhere near as well. Yeah, there's no norm, just a clip. Oh, you know what? I wonder if it's just, this. No, I wouldn't think so, honestly, but maybe? This could be it. Numerical guide, doesn't know RL. The thing about yet is you can know the math way better than I do, and the engineering will still bite you. We'll see how this goes, because I think I might have figured that out. Could just be the masking that was wrong. I would doubt it, but maybe. This doesn't seem like it matches the YOLO curve here, but... I'll run this, I'm going to set up the sweeps and go to bed. Oh, look at that. Look at that. We're going to shred this. We're going to absolutely shred this. Watch this.
These are my top writing tips. Number 1, before you start writing any essay, I would recommend drafting 5.
Power itself is defined as energy divided by time. And so pulse power is the engineering of taking and accumulating energy over a longer duration and releasing it over a shorter duration. And so if I take a single joule of energy and I discharge that in 1 second, it's 1 watt. If I take that same joule of energy and I discharge it in a nanosecond, that's now a gigawatt. And there's a lot of very interesting physics that can occur there. A lot of things that are very critical to national security, and so we execute research with various partners in the Department of Energy and the Department of Defense. So the United States right now is in a critical situation regarding workforce capability in pulse power and electromagnetic pulse sciences. At the end of the day, training students is the sole purpose of our job. And there's a need that is not being met by the existing infrastructure. So the Reese Technology Center is very unique in that it's an off-site location. It's a former Air Force base. It has access through active runways and things that would allow Department of Defense partners, private contractors and so on to fly in assets, and we would have the capability to test critical systems and components for their electromagnetic vulnerabilities. We're a very technologically advanced society, and from a DoD perspective, we're a very technologically advanced military force. And this is something that our adversaries are very cognizant of. And so if we look at other adversary nations, they are developing technologies that would threaten our electronics capability. And so understanding our vulnerabilities to the electromagnetic spectrum is one part of it, and then the other part is developing a capability to threaten other people's electronic capabilities.
Well, I mean, yes, I got the gist of that from our conversation before, and that's the very high level of it. Yeah, so this one doesn't match. Okay, so there's gonna have to be some sort of norm here. Okay. I'm trying to think where I can run this. Huh. It's funky. Triggers a full rebuild for some reason. It's fine. Okay, cool. That will now run. You have 2 active sweeps running. We will see what we get out of these by morning. Bunch of other work to do this week as well. There's very good progress happening, and just got to keep it up. So for the couple folks still watching, Puffer.ai. Start the GitHub, join Discord. We're almost at 1,000 here to get involved. If you're looking for content, got a blog right here with a quick start guide and some cutting edge stuff. Got services for companies. It's all open source still. You can follow me on X for more content. Almost at 7K here. It's all RL stuff. Alright, I'm gonna get some sleep. Night, folks, and I will be back probably for